Alright, let's pick it up where we left off, and I'm gonna go ahead and show you a way to kind of insert a graph mapper into this. And let's first of all identify where we're going to do that in here. We're going to be working between the distance component, so I'm going to highlight that, and this one. So it's going to be all between this action here. Okay, so I'm just going to go ahead and kind of move stuff over. I'm going to make some changes. Alright, so I'm going to highlight that. And now I'm gonna work in between here. Okay, so the first thing is going to be to figure out how many numbers we need. Again, we're gonna want still like a single set of values to control this whole thing. We don't want to be customizing what values go to what point. It's just unnecessary for this purpose. So let's first start with, sometimes I like to just start with the big component, the one that we're really gonna need, and then see what it needs and see what we want to feed it. Graph mapper I'm going to grab, from parameters input graph mapper, and I'll just go ahead and set a default to Bezier, I guess. I like to start with Bezier most times. Now this is going to be parameterized between 0 and 1, and we know that that works because we've already tested it over here with that slider. So we're going to end up replacing that slider with some new stuff. So we'll just leave that there as a reminder. Yeah, let's go ahead and go over to sets. And this is similar to what we did before, so we'll grab our range, and we can plug that in. Now, by default, what this is doing is telling us that we've got 11 numbers here, and we can kind of change what they are between its two boundaries, between 0 and 1. All right, but we need to know how many we need, actually. I need to know more information. I need to know how many distances I have, and for that, we can go over to, it's not quite as simple as just listing out the length like we did maybe last time, because we're really only going to get, because this is a data tree, we're going to get, in this case, 440 different lengths, and they're all going to be the same. They're all going to be 4, because it's actually counting how many items you have in each list. We want something else. So let's go to set tree. In fact, I'm just going to start this over and delete that out. And sorry, sets tree and tree statistics. Okay. And go ahead and bring your distance values into that. Let's take a look at what comes out of this. So we got first we have what our pads are, okay, whatever. What our lengths are, we know how long each one of those lists are, but we already kind of knew that. What we really want is this one, the number of paths and branches in the tree. All right, so actually what we want is this 440. We need 440 numbers. Another way to do this, I suppose, is to count how many surfaces you have. So another way to do this would be to go ahead and grab your list length and just bring it over from the surfaces themselves, because we know we need one number per surface. But since we already did it, I thought I'd introduce a new component. That's one that I use pretty often to analyze data trees. So let's go back and grab another one of these ranges. Okay, and our domain can stay as it is, 0 and 1. But the one thing that we want to make sure we always do here is if we're going to be bringing in a count from a different component, we are going to want to set our expression to this as x minus 1. You might recall that from an earlier tutorial. The reason is that instead of giving us out an extra, it'll give us the right number, 440. All right, so we can go ahead and plug that in, like so. Cool. Now, if I go and just kind of place a panel on this, just to give you a sense of it, we now have 440 values in between 0 and 1. All right, so it's sort of like broken up evenly with this really long decimal. And you can see that as I play around with the graph mapper here, I'm going to kind of massage those numbers. They'll stay between 0 and 1, but they'll change a bit based on where they lie along this curve on the graph. And we're almost there, but one of the things we have to pay attention to is our data structures and matching. We want to make sure we're going to be able to match what so here we have an input of 1,760 things. So that's 4 times 440. Okay, so we have 440 surfaces on the left, and we have 4 points each on the right. The kind of data we have coming out of here is not set up that way, right? It's just a single list. So that's going to be a bit of an issue. So in fact, if we were to bring this right up and through here, we may even crash the computer. I doubt it, but it would run really slowly for a while, and then what you would see is a whole lot of lines on screen. So we're going to need to graph this in order to do that. So let's go ahead and go to sets, and I'll do this slowly here. We'll just kind of bring in this graph components, the little one there with the little leafy symbol, so it's graphed tree. All right. And let's take a look now at what that data looks like. 440 branches, that looks like it'll match up nicely because we have 440 here. So that should be 0 to 439. Cool. And we can plug that into our min. So let's go ahead and check that out, see what that does. Okay, nothing broke yet, that's good. And we can see a gradient. All right. Now if I play with this, we should be able to get that to move around. There we go. Now this kind of works pretty well, you know, for something like this, which is only line work. All right. Let's use a different one. Also, I'm going to right click and go to graph types and just maybe click parabola. Okay. Let's get a different one going there. So let's go ahead and control this even further. I don't think we're quite done yet, because if we were going to turn these into surfaces, you know, we're going to have a problem in areas like that are stuck at 0 or stuck at a full move to 1. You know, we won't be able to draw a surface through that. It'll just be a single line. So we want to control this a little bit more so we can maybe build out some surfaces here. So I'm going to work between the graph mapper and that the grafting, and I'm going to set. So I'm going to go to math here, and I'm going to set a basically a limit by using the remap. So math, domain, and remap numbers is what I'll use. The numbers themselves are going to come out of the graph mapper. Okay. Our source domain can stay the same as 0 to 1 because that's already set by default. But we do want to construct a new one, so I'm going to go over to math and construct domain. Okay. And here's where I can set a couple of sliders custom. So I'll grab a new one. And I don't know, let's try something like 0.1 as a minimum, and maybe something like 0.585 or something as a maximum. And we can go ahead. So now the values coming out of here are going to be between, right, 0.585 all the way down to 0.1 and back up again to that other value, to the minimum value. We can check that real quick if we want, just by using one of these min-max, and there's our values. Okay, let's put that in. Pretty helpful, right? So now I don't have any situations, so I still have some space there, right? So I know that I can probably build surfaces. Nothing kind of collapses completely to being a line, although it gets pretty close over here, so you may want to control that even further. And yeah, that should pretty much do it. I mean, we can, again, kind of fine-tune that a little bit more so that our minimum, there we go. Maybe we can drop that a little bit lower, play around a little bit with this. And there we go. So now it comes back around pretty nicely. It's more subtle, but as I make changes to our graph, you know, back to Bezier or something, you can see that I'm making some effect, having some control over it, but now I have a bit of a tighter solution space. The overall amount of variety is actually well controlled within the parameters of what we think the next step is going to be here, which is to ensure that we have enough, basically enough space between the lines in order to build surfaces without collapsing them into being single lines. So I'm just going to leave the parabola one on here for a bit and let that sit. And now from here, it's mostly moving forward as we did before. Okay, so what I showed in tutorial 4 from last week is really will work here. What you need to do is set, you know, again, find the vector, the normal vector off each of the surfaces, the perpendicular vector, that is, the normal. And you can set, you know, things in motion. You can move a center point out, or you can move, you know, these points that are these midpoints out to create your three-dimensional surface or little set of components. All right, so with that, I think I'll I think I'll leave that to you. And if there's any trouble with that, obviously let us know. But hopefully this is enough, to kind of compare. Go ahead and compare this tutorial with the last one and see if you can fill it in on your own to go ahead and finish it off. Just to give you a little bit of a hint for where this student was going with it, I can pull that file over. And this is sort of where she's going with it. So that pattern you can see on the left of my screen here sort of gets converted into this. So the moved, there's a center point that's moved, and that center point for each square is then drawn to the midpoints that are being moved in plane. So we're creating these little kind of pyramids that scale accordingly as the gradient is applied. Many, many different ways to interpret this probably, but this is one of them. Okay. All right, super. Hopefully this is helpful to get you moving into some of your own work. But again, I think the big thing here was to kind of go between measuring, finding the logic of moving the points to a specific distance away, knowing where to put them. You don't want to set that manually, so what we're doing is extracting the center point so that we can figure out how far it is away, and then use that as a control so that the points never exceed it, right? And then from there was a little bit of, a couple new things introduced here in order to produce the gradient properly so that the data streams match up with one another. Remember that we're going to want that to match, right? Those two inputs there particularly, right? So all we're really doing is using a very similar technique as before. I'm introducing a remapper just to kind of control the surfaces even better, but really just making sure you're knowing when to graft and when to kind of leave the data alone, basically. In this case, we do need to graft it so that we have one particular value per surface, because that's how it's set up over here, because we have 4 points per surface. If you were only moving a single point, you really wouldn't need to do this, because the list should align anyway, but it's helpful. It wouldn't be a problem if you did. But you definitely have to do it if you have multiple items per list and you're trying to match that with a single value. So you want that single value to be basically constructed or organized in the same way that the data is that you're applying it to. Okay, so we'll leave it at that, and I can follow up on this one if necessary to build out the surfaces as well. But hopefully you'll be able to fill in the blanks.